3. And we're live finally. Yes.
Hello everyone. We are going to start the session in just 5 minutes. Hey everyone. So today we will talk about V8 engine, which is a JavaScript engine. And if you use JavaScript, you might already know what is a V8 engine. If you don't know, I assure you that by the end of this session, you will have a pretty good idea of what exactly V8 engine is. So V8 engine is actually a JavaScript engine that was developed for Google Chrome initially. Before I think it was in 2008 or 2009, and now it is being used by not just Chrome but also by Microsoft Edge and Node.js as well. So let's start the session. But before we start, so I am going to open the question answer. So what you're supposed to do is that if you have any question, please ask them here in this in the link that I just sent on Teams. So if you have any kind of question, please do share it there so that I can review that on my screen as well for everyone. So I will be looking at the questions if you have any in between the session. So let's start it. So let me introduce myself. So I am Aksaran Khatak. I am a former MLH fellow, and now I am working at MLH as a junior team lead. I am a GitHub campus expert, and by profession, I am a full stack web developer. So my stack is MERN stack, which is React and Node.js, and I am also a DSC lead and a Gold Microsoft Student Ambassador. If you want to connect with me, my handle almost on every platform I use this just one handle, which is khatakdev. So on Twitter, on GitHub, on LinkedIn, almost on any platform, I have just one handle, that is khatakdev. And my portfolio on my website is also khatak.dev. So if you want to connect with me, please do. I love to connect with people and network with them. So now let's start the session with the JavaScript engine. So the first question is, what exactly is JavaScript engine? Do we need a JavaScript engine? What is the purpose of JavaScript engine? So the JavaScript engine helps to convert the code from the JavaScript engine helps to convert your JavaScript from the source code to a machine readable format. That is why JavaScript engine is something extremely essential to execute your code. So if the browser does not have engine, if it does not have the JavaScript engine, it will be unable to help you execute your JavaScript. So that is why JavaScript engine is something extremely essential. Also, let me turn on my camera. Yep. Yeah. So now each browser uses a JavaScript engine. So we have like different engines. So Chrome, so the most famous and the most popular engine is V8, which is the engine that we will talk about in this session. And the reason for choosing V8 is that V8 is the most famous one, and it is used by many different browsers. So V8 is used by Chrome, Microsoft Edge, and Node.js as well. There's another JavaScript engine that is known as SpiderMonkey, which is being used by Mozilla Firefox. Internet Explorer used to have an engine that was known as Chakra. Safari used an engine that is known as JavaScript Core. So each of the browser has their own JavaScript engine. And if you talk about Node.js, so Node.js also uses V8 engine. So it takes, with the help of V8 engine, it executes your code behind in the backend, which was not possible before. So V8 is the only engine that is used by multiple browsers as well as by a runtime environment, which is Node.js. So now we have understanding of what exactly are JavaScript engines. Now let's understand about JavaScript. So let's see whether JavaScript is a compiled language or it is an interpreted language. So basically we have like the two types of languages. The one is interpreted, and the other one is compiled. So the first one is, and the interpreted languages are those languages which we use in interpreter. And the job of interpreter is to go line by line and check each of the line and execute that single line at a time. So languages like PHP or Python, they use interpreter. So like if you have some bug on line number 5, the other 4 lines will work correctly and you will get the result. But on line number 5, it will stop. Then we have this compiled languages, for example, Java or C++. So if you have the job of compiled language is the working behavior of compiled language is that it first compile your whole code to a machine language and then execute it. What that means is that if you have, for example, a bug on line number 5 in Java or C++, so your code will not run at all. It will give you this issue that this bug that there is some bug in that line number. So you need to first make sure your whole code works fine, and then you will be able to compile that. So compile your code at once and then execute it, while interpreter execute your code line by line. So that is the difference between interpreter and compiler. Now, the difference and the plus points between interpreted language and compiled language is that interpretation helps you in faster execution, but lack of optimization. Whereas compilation helps you in optimization, but it's slow when it comes to execution. Because when it first reads the whole file and converts it to machine language, so that takes some time. But as a result, the plus point is that when it gives you the machine code, machine readable format code that is already optimized. Whereas in interpretation, the execution is fast, but it does not focus on optimization. So what JavaScript does is that JavaScript use best of the both worlds and use this other other working, which is JIT compilation. JIT compilation means just-in-time compilation. So it takes the interpreter and it takes the compiler and use both of them. So it takes the plus point of interpreter and the plus point of compiler and use just those. So which helps JavaScript in faster execution and optimized code. Java is also a JIT compilation. C++ is a compiler. So JavaScript and Java, and there are some more examples which uses the JIT compilation technique. So now you have understanding of what is JavaScript engine, what is why is it essential, and about this is whether the JavaScript is compiled language or interpreted language. So now let's talk about V8 engine. So V8 engine is a JavaScript engine developed by, initially it was developed by Google for its browser Chrome, but now it is an open source project written in C++. So V8 can also be used as a standalone package too. So that is why Node.js is able to use it behind the scene. So there are several steps that V8 engine takes to convert your code, and we will talk about that. So this is the general flow of V8 engine. This is the top level overview of how your code is converted. So I will talk about each steps in detail, but the general idea is that your engine, the JavaScript engine, takes your source code and it passes that code to abstract syntax tree. So once it passes it into abstract syntax tree, then it uses the ignition. So ignition is a component. Again, I will come back to each of these component and each of these steps in detail, but just give me a quick overview of a top level of overview of how this happens. So it passed that source code into abstract syntax tree, and then this abstract syntax tree is moved to ignition. Using the ignition, the abstract syntax tree is converted to a bytecode. So bytecode is a form of code, like just like the source code, we have this bytecode. And this bytecode is then used by the engines. Some part of the bytecode is then moved to turbofan. And turbofan is again a component. So what does the turbofan do is that it optimizes the code. So it gives you an optimized version of the code. So how it exactly works and what part of the code is moved to the turbofan, I will talk about that when we comes to the turbofan section. But the general idea is that JavaScript engine takes your source code, convert that to abstract syntax tree using the parser, and then it gives that syntax tree to ignition, which convert that to the bytecode. And some part of that is then moved to the turbofan, which convert that to the converted to optimized code. So here, the ignition does the interpretation job. So it interprets the code and switch that to bytecode, whereas this turbofan do the job of compilation, and it compile your code and give you an optimized version of that code. So now let's talk about in details about each component. So first, let's talk about parsing. So there are two steps in parsing. The first one is lexical analysis, and the second one is syntactical analysis. So before we pass the code into an abstract syntax tree, which is AST, we first convert it into tokens. So this conversion to tokens happens in lexical analysis. this phase, which is called lexical analysis. So a scanner, there is a scanner in this phase, which consume a stream of Unicode characters, which here you can see this var num equals to 42, and it combines it into tokens. Like here in this example, you can see this. We have tokens, which is var num equals to token, and each of them has this token type. So it categorizes them on the basis of their type, and remove all the white spaces, new lines, comments, etc. All those things which are not necessary. So these tokens are keywords, operators, etc. So once we have these tokens, we then JavaScript engine shift to the syntax analysis. So once the engine convert your code into tokens, it's time to convert it into abstract syntax tree. Here you can see this how abstract syntax tree looks. So this is a JSON kind of format. So the tokens are converted to AST using the V8 parser, and the one more thing that happens here is that the language syntax validation also happens during this phase. So your parser, the V8 engine parser makes sure that the syntax that was provided is valid. There is no invalid syntax in the code. So that is something that also happens in this phase. Now, just a second. Yep. So now we talked about parsing and how parsing happens. Now let's move and see ignition. So ignition is most essential component of V8 engine, and you will see why is that. So the job of ignition is ignition is a component that helps you to interpret your code. So once the engine has this abstract syntax tree, it sends this tree to this ignition, and this ignition convert or compile this into the bytecode, and then this bytecode is interpreted by a high performance interpreter. So here the interpretation takes place in this ignition component. So it takes your abstract syntax tree and compile that to a bytecode. So again, it does the compilation here, interpretation here, and do this interpretation line by line. Now, once we have the bytecode, then let's talk about the turbofan, and then we will see how the turbofan and ignition works together. So in the turbofan, we have the bytecode, and some part of the bytecode, like it's not like all the bytecode is sent to the turbofan. There are some part of the bytecode, and we will see what exactly that part is. So we have this bytecode, and that with the help of the turbofan, it is compiled to the machine language. So here the compilation takes place, and once we have this machine code that is much more optimized, and after getting this optimized code, the result of the reason for getting this optimized code is that to execute your JavaScript code much faster. So turbofan helps you to convert your bytecode to an optimized version. So that is the job of turbofan, to compile your code to an optimized machine code. So now we understand what is the job of ignition, which is to convert your code to a bytecode, and it interprets your code. And the job of the turbofan is to compile your code to an optimized version. So now let's see how it works, like how both of them works together. And if the JavaScript engine, V8 engine, combine these two to make sure that it has smooth performance. So again, I talked about JIT compilation. So with the help of like combination of these two, it is possible, and the JIT compilation is possible because one does the interpretation and the second does the compilation. So which results in a smooth performance. Now let's see how that smooth performance happens. But before that, before we dive into that, let us first understand some keywords, some terms that we are going to use. So let's first understand those. So let's first understand a term that is known as hot code. So a function or a chunk of code that is repeated several times in your code is known as a hot code. An example of this is this function. So we have this code snippet which has this function, which is calling this function do something awesome for 100 times. We can see this, it has this function is being called in this loop, which will execute for the 100 times. So this chunk of code, this function do something awesome is a hot code because it is repeated several times. So that is called hot code. So something that is repeated severally, that is called hot code. Another thing is type feedback. So a type feedback is something that, for example, here we have this numbers equals to 1, 2, 3, 4, and then we are mapping. So map is, if you don't know about mapping, so map is a function in JavaScript that it creates over each of the keyword, each of the index, like 1, 2, 3, 4, and so if you notice here, we have this 1, 2, 3, 4, all of them are integers. So while iterating over these numbers, so JavaScript engine is clever enough to guess that, to understand that all the numbers, all the indexes here in the numbers are integers. So it collects a feedback from here, and the feedback is that x is a number, like x will always be a number. Our index in all the indexes in the numbers will always be numbers. So that is a type feedback. So again, the type feedback is collecting like what is the type of some integer, or what is the type of some array. So here we have 1, 2, 3, 4, and all of them are numbers. So that is collected by JavaScript engine, V8 engine. So now we understand what is hot code and what is type feedback. So now let's see how exactly the V8 engine works and how what part of the code is being bytecode is sent to the turbofan to optimize it. So again, we have the source code. It is moved to the parser where it converts that to the abstract syntax tree. And so I'm getting a few questions, so I will come back to that in just a few minutes. So we have the source, and that is moved to the parser, and then which is converted to abstract syntax tree. Then it is moved to the ignition. Again, ignition is a component that interprets your abstract syntax tree. And once we have the code converted to bytecode, which is not optimized, then it checks for the hot code in that code. Again, the hot code is that part of code where we have like something repeated several times. That I showed you where we had do something awesome function executed for 1,000 times. So it checks for the hot code there. And if there is hot code, it collects the type feedback from there. So it just collects the type feedback from the hot code, not from any other part of the code. So once we have the type feedback, once we have the hot code is being sent to the type feedback is being sent to the turbofan, and then that hot code is also being sent to this turbofan, and then with the help of this type feedback, we get an optimized version. We get an optimized code. So that is a bit confusing, but I will give you an example of that. So, but again, to repeat that, JavaScript engine look for the hot code in the bytecode. Bytecode is a code that is repeated several times, and if it finds a hot code, it takes the type feedback, and type feedback is gathering the data about what is the type of that code, or any variable, or any integer, any array, etc. So it takes the type feedback and send it to the turbofan, and then also the hot code is being is sent to turbofan. And with the help of this turbofan, with the help of this type feedback, turbofan optimize that code, compile that code, and gives you an optimized version of that code. Let's understand that with an example. So here we have an example. So this is a screenshot from ESPec, JavaScript specs. So this is the code for addition. So you can see, right, it has these several steps, and the most of steps are looking for the type, like is it a string, is it an integer, is it something else like that. So if once the JavaScript engine takes the type feedback, it sends that to the bytecode. So for example, the example that I showed you initially, where we had this numbers 1, 2, 3, 4. So there we had other numbers, other indexes were numbers. We had no string, we had no object or anything else. So for that, like for that algorithm, we if you want to map that, like if you want to use the addition operator there, we know that by the help of the type feedback, we know that there is no string, there is no object, there is no other type except from numbers. So what we can do is that we can optimize this code, optimize this algorithm, and remove some part of that. So to optimize that, you can see like initially like we have this 12 steps. So if we just go and pick the steps that are required for numbers, so we can reduce that to 4 steps. And what that means is that the rest of the 8 steps are looking for types, like if there is some string or if there is some object or any other type. So for that, we have those other algorithms. So if we reduce the algorithm, if we reduce the steps, so that means that we have less code, and we don't need to worry about those other checks, those other cases. And that is why we get this 4 lines where it will execute it for all the numbers. So we end up with an optimized code, and that is so again, like if you take this code and convert that to the machine code as compared to this one, so this one will be much more optimized than the previous one, because it does not have any unnecessary checks, because this will just do the job for the numbers, because we by the help of the type feedback, we know that the JavaScript engine know that it has just the types. So it has just the number, so that is why it doesn't need to care about strings or objects or arrays or functions or anything like that. So that is how it optimized the code. So again, just to go back here, so we have the source code, which is taken by JavaScript engine, converted to the abstract syntax tree, which is then parsed. And then the abstract syntax tree is moved to the ignition, and that ignition convert that to the bytecode, and JavaScript engine look up for any hot code, and if it find that hot code, so then it checks for the type feedback there, and then that type feedback is sent to the turbofan along with that hot code. For example, this case, so when we have some addition, so then by the help of the type feedback, so if we have just numbers, so we just reduce that and remove the unnecessary checks, and then we end up with the minimized version of that algorithm, and that is called the optimized code. So then whenever if that function is called again, the JavaScript engine will not go for the bytecode, but it will go for the optimized version. So like if there is again any addition in that code, so it will not go for this algorithm, but it will go for this algorithm, which is shorter. So to conclude it, so code is passed by abstract syntax tree. Code is passed to abstract syntax tree by a parser, and then ignition converts it into a bytecode, and interpretation reads it. So if ignition finds any hot code, any code that is repeated several times, it makes an assumption, which is the type feedback, and sends it to the turbofan. So the turbofan uses those assumptions to generate an optimized version of the code. One more thing to keep in mind is that, so if in case like in future, if it finds that that code does not have any more just numbers, but it also has the strings, so then the turbofan, the optimized code will be destroyed, and the JavaScript engine will not take that optimized version, but it will go for the bytecode again. So that is to make sure that we don't end up with some unexpected results. So if, for example, all the times we have just numbers, and then suddenly something happened, and then we have a string as well there. So in that case, it will not go for that optimized code, but it will go for the bytecode again. So that is how it works. So now let's go with a few questions. And before that, so I'm going to send a feedback form. Please fill that out, which will help me to improve my presentation or slides in the future. And then I will move back to the question. So I just sent the, feedback form in the team. So please fill that out, which will help me to improve my presentation or slides in the future. And then I will move back to the. I just sent the feedback form in the team, so please fill that out, which will help me to improve my presentation or slides in the future. And then I will move back to the fill that out, and meanwhile, let me answer the questions. Okay, so the first question is JavaScript compiled only if there is a hard code, otherwise it is interpreted? Yep, so if, for example, let me go back to the slides. So if we have this code, so if something like this happens, like this, so you can see like it is calling this do something awesome 1,000 times. And if we have like unoptimized version, like if there is some room for optimization, then it is the best choice is to go for that optimized code, so that we end up saving some, we end up doing some improving the performance. So we just go for the hard code, and that hard code is compiled. If there is no hard code, it will interpret that. So that is why to improve the performance, we have the compilation. As if we don't have the hard code, so then that means that each of the code is different, and each of the time we have to compile that, and that will then that will result in like slow performance. So that is why compilation only happens if there is a hard code. Otherwise, it is interpreted. Another question is, why do we need to create the abstract syntax tree at all? So that is something that works in every language. So that is the initial flow of how things work. So especially in JavaScript. So it must be converted, whether it is your browser or whether it is your Node.js. Everywhere you use the JavaScript, it must be converted to tokens. It must be converted to an abstract syntax tree, because that syntax tree is something that but if you want to convert, if you want to take your source code and just convert that to your machine readable format directly, that is not possible, because it does not understand that. So that is one of the phase. Just like your machine does not understand your source code, it needs to be converted to machine readable format, like the binary code. This is in the same way, your source code needs to be converted to abstract syntax tree in order to the ignition to use it. So ignition does not understand your source code, it understands the abstract syntax tree. So another question is, isn't making an abstract syntax tree memory inefficient? So I don't know about that details of like that lower details of like how much inefficient or efficient abstract syntax tree is, but it is again something that is must for the engine, because your code, your ignition does not understand your source code, and also it is something that happens just once. So for example, if there is some code that needs to be executed like multiple times, that will again just be executed. That will be just converted to abstract syntax tree just once, and then that will be converted to bytecode, and then your bytecode will be used. So abstract syntax tree is just converted once, and then that is not used again. The thing that is used is your abstract syntax tree. Sorry, your bytecode or your optimized code. Is machine or optimized code refers to assembly? So the Chrome actually use the bytecode, so it can understand the bytecode and it can execute that. So if you go to Google and search for the bytecode example, so you will see it looks like assembly language, and but again, I am not exactly sure is it that assembly language, but I think it is not assembly, it is something, right? It is again a low level language, but I'm not sure whether it is assembly language or not. So is there any good documentation where I can learn about more about V8 engine? Yep. So V8 has their own website, which is v8.dev. So you can go there and you can learn about what is V8 engine and how it works, and it has like a lot of details about how it works and how everything works it has ignition, interpretation, compilation, turbofan, even the garbage collection, and all those things that is also mentioned there. So you can go to v8.dev and search for that. And let me see if I can, just a second, let me see if I can share the my browser, and I will show you which website I'm talking about. Yep, so this is the website I was talking about, so v8.dev. So here you can find almost everything about V8 engine, and you can see it has the blog and documentation, and even if it also explained the JavaScript specs as well. So there are a few articles on understanding the ECMAScript like this, understanding the ECMAScript. So you can also, if you are interested in ECMAScript, the documentation, you can also learn that from here. So, and you can see this high performance garbage collection in C++. What are the, it also writes, it also has the articles about the updates of V8 engine. So if you want to know about V8 engine, this is the website that I prefer. Okay, so this other question is, does making Node apps for non-V8 engine browsers cause any issues? Not at all. So if you have seen, or if you have built some Node.js apps and you try to execute that, you try to use that. So Node.js is actually like, it is not, like that does not mean that using the V8 engine for the Node does not mean that you have to use V8 every time you execute your code. It just use that to convert your code and make sure that it executed. If you execute your code, if there is a Node.js app and you are using some other browser, for example, Firefox or Safari or some other browser, that will also work. So there is no issue with that. That does not cause any kind of issue. And this one is a kind of off topic, which is what is MLH Junior Team Lead. So if some of you, if you are not, if you don't know about MLH, so MLH is a community. Their website is mlh.io, which is this one. So they have this kind of internship program for the open source. So just like the Google Summer of Code. If you want to know more about that, so it has this first article which is introducing the fellowship, or this MLH fellowship is back. So they teach you about open source. So if you are interested in that, you can apply for that. So I am actually working there as a team lead. So my job is to help the fellows, help the people and the students who are there as contributing to the open source, and my job is to assist them and make sure that everything works smoothly. So that is the MLH Junior Team Lead. All right, so we don't have any more questions. Again, if you have not filled the form, the feedback form, please do that. I have already sent that in the live Q&A, so please submit that. And thank you everyone for joining. And if anyone has any more questions, please do ask, as let's wrap up the session. Okay, so we have one other question, that is V8 engine included in Chromium? Yes, it is. So recently what happened is that, okay, so the question is that, is V8 engine included in Chromium or in Node.js? So V8 is actually a standalone package that is like not dependent on Chromium or Node.js. it is standalone. You can go to GitHub, you can clone the engine, and then you can use it without any other dependency. So it is independent, but it is used for Node.js and it also used for Chromium. So since Microsoft Edge moved to Chromium, so that is why they are also now using V8 Engine. But it is V8 Engine is a standalone package, and it can be used independently without using any other package. All right. So it looks like we don't have any more questions. So I'll stop sharing my screen. All right, everyone. Thank you so much for joining, and thank you so much for filling the feedback form. If you still have any more question or anything, always feel free to connect with me on my social media, which is again this. Khatak Dev. So if you forget that for some reason, go to khatak.dev, and there you can see my Twitter or GitHub or LinkedIn. So if you want to connect with me, please go ahead and connect with me. Thank you, everyone, and have a good day.